We from Group 8, Session 2, Subject Fluid Mechanics, we want to present about project piping design.
My name Haniza binti Poli, matrix number CN190030.
My name is Saiful Akmal bin Shamsuddin, metric numbers 190192.
My name is Muhammad Luqman bin Hairuan, matric number AN 190050.
I am Xie Chengwen and my metric number is AN1901F5.
Fluid mechanics is the branch of science that studies the mechanics of fluid and the force of them. The importance of fluid mechanics cannot be described using some topic because it has a wide range of use. There are many large structures of performing work done for the help of using fluid mechanics. But there are many things that we don't know about it. There are many applications of fluid mechanics that are related in our daily life, such as when we apply makeup. When we apply makeup, we use shear and pressure force. When we trying to put eyeshadow or powder on our face, when you put foundation on a sponge and smear it over our face, we can feel the shear stress acting on our face because the shear stress increase as the foundation move from the sponge to the face. This causes no slip at the boundary, which allow the foundation to stick on our face rather than slide off. Second, when we using lotion, we don't know that we use pressure force to the container when we trying to squeeze the container to get lotion out. Next, once the container is set upright, the lotion will slowly slip down to the side of the container. Since the lotion is coming out, contact side of the container, shear force are present. This situation is representative of quick flow. Next, when we washing dishes. When we washing dishes, the extra soap on the dish became slippery. I realized that this because the soap was acting as a lubricant for the dish. The viscosity of the soap lessened the effect of the shear force on the plate. This is what caused the plate to slip out of our hand. And likely, when we making coffee, once the creamer was poured into the coffee, we thought about the design of the container. We noticed that the flow of creamer into the cup was laminar rather than turbulent and wonder why. Because we noticed the container had a curved point from which the fluid flow. We decided that this design inhibited the flow of the creamer particle close to this point. As a result, this allowed the remaining creamer to flow slower, which led to a less turbulent flow. That's it. Civil engineering technology play a big role in our daily life, such as hydroelectric power plant. In hydroelectric power plant, water is used to generate electricity on a large-scale basis. Water stored in a dam possesses potential energy, which is converted into the electrical energy in the power generation unit of the plant. Hydroelectric power plants are one of the major suppliers of power throughout the world. In some countries, power requirements are fulfilled entirely by this plant. Hydraulic machine. Like we know, machines that operate on a fluid like water and oil are called hydraulic machine. The fluid has the capacity to lift heavy load and exert extremely high pressure. Some hydraulic machines are used to perform various machining operations. In most of these machines, oil is used as a fluid. The oil is passed through the hydraulic motor, which transfers large amount of energy to the fluid. This high energy fluid into the piston and cylinder arrangement where it can be used to lift heavy load or apply large force. Next is automobile. No automobile can run without fluid. Fluid can perform three crucial operations in automobile: generation of power, lubrication and cooling of the engine. Petrol or diesel generate power on combustion in the engine. This is commonly referred to as fuel. Oil is used for the lubrication of the engine and the gearbox, and also various other moving parts of the vehicle. In larger automobiles like car, bus and truck, water is used for cooling the engine. Last but not least is nuclear power plant. Water is again crucial power plant component. Here is both the working fluid and a coolant. In some nuclear power plant, heat produced within the nuclear reactor is used to directly heat water, which is converted into steam. This steam is passed through the turbine similar to thermal power plant, rotating turbine blade to generate power. This is an application of water as the working fluid. In other nuclear power plant, the heat from the nuclear reactor is not used to generate steam directly. Heat is first used to heat the water, which acts as the coolant. This coolant then transferred to heat to a secondary coolant or the working fluid, which is again water, and is passed through the turbine to generate electricity.
Introduction of design. They are given two places: Beckett Reservoir, Yongping Water Treatment Plants. First, Beckett Reservoir or Beckett Dam is located in the mid-western part of the state of Johor. It's located about 6 km off the Yongping-Segamat Road and is also accessible by electric roads, so that the pipe from Beckett Reservoir will connect it to supply raw water to the Yongping water treatment plants for process before received by consumer. Yongping water treatment plants. The water treatment plant is a place for any process that improves the quality of water to make it more acceptable for a specific end use. Yongping water treatment plant is a place that process raw water from the Beckett reservoir so that a set piping must be designed for the allowed water. Commonly, dams are located at high elevation above sea level, so that the commonly water treatment plant is located at below places. This is our group pipe design that connected from Beckett Reservoir to Yongping water treatment plant. We design water flow pipe through two types of diameter pipe, which is pipeline 1. It have 100 mm diameter with a length 1.9 km and connected using expansion to pipeline 2. It have 150 mm diameter with the length 2.6 km. Both of pipe are designed by using material cast iron pipe. Pipe were designed in series type because the height between Beckett Reservoir and Yongping water treatment plant is 8 meters.
For the question 2, we assume that the length of pi 1 and pi 2 is 1.9 km and 2.6 km, and the diameter of the pipe is 100 mm and 150 mm. The elevation difference is 8 meter. We assume that the 2 pi is cast iron pipe. Calculation and the result. Since the 2 pi is cast iron pipe, so the roughness coefficient is 0.25 millimeter. By using common method, we can get the friction factor of pi 1 is 0.025 and the friction factor of pi 2 is 0.022. Through the continuity equation, we can get the velocity of pi1 is equal to 2.25 velocity for pi2. Through all of these equations, we can get the total head loss is how many times of square velocity for pi2 per 2 times gravity. Through the Bernoulli equation between 2 pi, we can get the rate of flow is 4.24 times 10 power negative 3 meter cube per second. By using the table of calculation of head loss, we can calculate all the loss. After all calculation, we can get the result that was shown in this slide. This is the EL and the HLG for the system that we sketch.
Hi, I'm Haniza will present discussion and investigation. For question 2, applying the Bernoulli equation. The Bernoulli equation states that where points 1 and 2 lie on a slim line, the fluid has constant density, the flow is steady, and there is no friction. The Bernoulli equation is very useful, partly because it is very simple to use and partly because it can give great insight into the balance between pressure, velocity, and elevation. Apply the Bernoulli equation for pipe 1 and 2 in mathematical term, which is the formula same based on the slide shown. H is the height difference between the level of liquid in two tanks. The value of H is provided, which is H equal to 8 meter. Solution apply for assumption value. That is, the question state the feasible pipe distance proposed is 4.5 km for a water pipeline connecting the Becker Reservoir to the Yongpeng Water Treatment Plant. The reservoir and the water treatment plant will be connected by a pipeline 1 and pipeline 2. By using the distance, we assume that the length of pipe 1 and 2 are 1.9 km and 2.6 km. Based on the length of pipe 1 and 2, we assume that the standard diameter for cast iron is below 100 mm and 150 mm. Friction factor F is a function of both the Reynolds number and the pipe roundness height. For fully rough pipe flow, common equation can be used and will lead to the value. The formula same based on the slide shown for pipe 1 and pipe 2. Applying the head loss equation, the total loss of energy or head will be the sum of the losses each pipe plus local losses at connection based on the formula on the slide shown. Major loss. Major head loss is present due to friction in pipe and ducts. The minor losses are also being calculated to determine the total head loss exists in the whole system. The minor losses are any head loss present in addition to the head loss for the same length of the said pipe. Entrance loss and sudden expansion loss. The losses in the system due to the friction must also be calculated. The formula same based on the slide shown. Exit loss. Exit losses are opposite and come from liquid leaving a pipe and entering a much larger pipe or tank. All kinetic energy in pipe is dissipated. Therefore, K equal to 1.0. The result of time from the calculation leads to the value. By using the formula as below, the total head loss is same based on the slide shown. Apply the flow rates equation. Q equal to 4.24 times 10 negative 3 meter cube per second. Thank you.
The conclusion is fluid mechanics ideas are utilized differently in our everyday life. The standard are utilized on straightforward things to advanced science. Drinking water, filling petroleum, blood gas, bubbling liquid, weather gauging, in vehicle, optimal design, submarine, ship, renewable vitality, HVAC framework and others. Liquid repayment is a significant things that consistently used by humans for proceed their life. Without fluid mechanics, numerous issues will happen and humans can do numerous things in their life. With the pipe being planned by our group, the water grading in the funnel will diminish and the weight will quicken the development of the water without unfavorably influencing the pipe. As a future technologies, we should know the significance of the liquid mechanic and the utilization of them so we can undoubtedly utilize them when the correct circumstances come. By doing that, we can contribute a great deal to humankind.